Welcome to this e-learning module on Fundamentals of PLC. Click Start to begin. Let me quickly show you some important features of this module. You can pause or play the module at any time by clicking this icon. If you wish to view the list of various sections, you can click the menu button here. You can also move back and forward with the help of these buttons. You can go to the home screen with the help of the home button. Quite simple, isn't it? Now, click Next to continue or replay to go through these features once again. Before we start the learning module, let us take a quick check of your current knowledge of Programmable Logic Controller. Click Start to begin. After a month of joining Tata Steel, one day Ramesh meets Mr. Prakash, who is a senior manager at the electronic department. So, Ramesh, it has been a month since you joined Tata Steel. How has your experience been so far? It is wonderful, sir. This is such an amazing place, and I'm learning a lot about the way in which a lot of huge processes are automated with electronics. Good. At Tata Steel, we have some of the best technology and automation to enhance the efficiency of our works. Sir, is there any particular component or part which makes all this happen? Automation is a complex process, but as I have a little time before my next meeting begins, so let me tell you something about a very important component called PLC. A programmable logic controller, commonly known as PLC or programmable controller, is an industrial computer used for automation of typical industrial electromechanical processes, such as control of machinery on factory assembly lines, amusement rides, or light fixtures. PLC is a system that continuously monitors the state of input devices and makes decisions based upon a custom program to control the state of output devices. Almost any production line, machine function, or process can be greatly enhanced using this type of control system. Click Next to continue. The tasks performed by programmable logic controllers are scanning, I/O bus traffic control, and device communication. PLCs are used for discrete or continuous control functions, producing on or off voltage outputs, and actuating elements such as motors and solenoids. Click Next to continue. This is amazing. Although we don't see PLCs, they seem to be everywhere. Yes, they have been transforming the manufacturing sector since 1968. take a look. Gold Modicon in 1968 was the first company to build PLC as per the design criteria defined by the automobile industry. Later in 1970, Alan Bradley came up with the first programmable controller and commercialized it with the trademark Programmable Logic Controller, PLC. Click Next to continue. While PLC might seem to be complex, it is easy to understand if you begin by learning about the fundamentals of its operation. Process control involves recognizing the state of the process at all times, processing the information according to the set rules and guidelines, and accordingly actuating the control elements. In the controller process, all the actions can be taken manually with human involvement or in semi-automatic or fully automatic manner. Click Next to continue. Automation can be defined as a set of technologies that result in operation of machines and systems without significant human intervention and achieves performance superior to manual operation. It is basically the delegation of human control function to technical equipment aimed towards achieving higher productivity, superior quality of end product, efficient usage of energy and raw materials, improved safety in working conditions, etc. Let us now learn about basics of PLC. Click Start to begin. The primary components of a PLC are the input module, central processing unit, CPU, output module, programming device, and the operator module. Click each icon on the screen to learn about the component. The input module accepts a variety of analog or digital signals from various sensors and converts them to logic signals that can be used by the CPU. The CPU makes decisions and executes control instructions based on the program in its memory. The output module converts the control instructions from the CPU into signals that can be used to control various field devices. A programming device is used to install the instructions that determine what the PLC will do in response to specific inputs. A programming device is used to install the instructions that determine what the PLC will do in response to specific inputs. The operator interface allows process information to be displayed and new control parameters to be entered. Click Next to continue. Now that you are familiar with the fundamentals, let me explain the working of PLC to you. In this simple example, you can see a motor starter, PLC, and push buttons. The push buttons are connected to the input side of the PLC and the output side is connected to the motor starter. Using the PLC, the push buttons can be used to start or stop a motor as required. I am quite clear about the fundamentals of PLC. Well, then let me see how much you have learned. Click the images where PLC is in use. Correct. Correct. Incorrect. Click Next to continue. You are doing quite well today. So much of automation? It is impressive. I wonder, it must be costly. Yes, initial investment is little high, but they tend to be cost-effective in the long run. Let's look at some of the advantages. Low power consumption, energy saving. Troubleshooting is easy and fast. Reliable in operation with high-level human safety. Small in size, flexible and easily programmable. Easy to maintain due to modular assembly. Easy to monitor input and output by HMI, that is, Human-Machine Interface Support. Capable of communicating with computer in plant. Good documentation. Sir, I am curious to know how big a PLC unit is and what are the most commonly used PLC brands in industries. Leading brands of PLCs are USA PLC, Rockwell, Emerson, General Electric, Honeywell International, Europe PLC, Danieli Automation, ABB, Siemens, Schneider Electric, Japan PLC, Mitsubishi, Omron, GE Fanuc, Fuji, Panasonic, Hitachi, Taiwan PLC, Delta, Fatec, China Mainland PLC, Kinko, Innovance. PLCs come in many shapes and sizes. Based on size, they are classified as small, covers units with up to 128 IOs and memory storage up to 2 kilobytes. These PLCs are capable of providing simple to advanced levels of machine controls. Medium, covers up to 2048 IOs and memory storage up to 32 kilobytes. This is most commonly used PLC in industries, which allows many plug-in modules that are mounted on backplane of the system. Large. It is the most sophisticated unit of the PLC family. These are used wherein complex process control functions are required. They have up to 8,192 IOs and memory storage of up to 750 kilobytes. It can control individual production processes or the entire plant. And 192 IOs and memory storage of up to 750 kilobytes. It can control individual production processes or the entire plant. Well, many popular brands manufacture it. Any particular type of PLC that we prefer to use at Tata Steel? Yes, most commonly used PLCs in process industries are Siemens. Get yourself familiar with Simatic S7 PLC. SIMATIC S7300 and SIMATIC S7400 PLCs are used at most Tata Steel plants. SIMATIC S7 platform supports three types of programmable logic controller families classified according to their performance range: S7200, S7300, S7400. S7400H are hot redundant system, that is, two identical PLCs working in parallel. All PLCs from S7 family are compact in size. What does a PLC consists of? Yes, they are comparatively small in size. All these are modular PLCs, also known as rack-mounted units. It allows many independent components. Take a look at hardware components of a PLC. Let us now learn about hardware of PLC. Click Start to begin. Following modules can be used in an automation system: chassis or rack, power supply unit, PS, central processing unit, CPU, communication modules, CP, signal modules, SM, function modules, FM, interface modules, IM. Let us know about each one in detail. The rack is the component that holds everything together. It is the hardware which is configured first. Rack has cabinet for placing the modules. It comes in two sizes, 9 slots and 18 slots. It provides interconnectivity between modules. Rack are of two types: passive backplane. It has only the slots and very little or no additional circuitry. It is used in S7300 PLC. Active backplane contains slots as well as the necessary circuitry to control communication between the slots. It is used in S7400 PLC. In S7400, CPU can be placed in central rack, CR and universal rack, UR, but not in expansion rack, that is ER, because ER has only P, peripheral bus, and no K, control bus. The power supply module provides required level of regulated power supply to the different modules in the rack via system backplane bus. They do not provide load voltages for the signal modules. 220-volt AC UPS power system is given to the power supply module of PLC. It generates 5-volt or 24-volt DC. In some model, battery is also installed for backup of RAM, which has program memory of CPU. The brain of the whole PLC is the CPU module. This module typically lives in the slot beside the power supply. The CPU has different operating modes. In programming mode, it accepts the downloaded logic from a PC. Program editing can be done in this mode and stop mode. The CPU is then placed in run mode so that it can execute the program and operate the process. Memory reset mode is used to reset the memory of the CPU. The signal modules provide an interface for the field input and output devices to the programmable controller. They are classified as digital I/O modules and analog I/O modules. Inputs. It carries signals from the process into the controller. Inputs are of three types: digital, analog, and variable frequency. Examples of digital inputs: push-button switches, selector switches, emergency stop, limit switches, proximity switches. Examples of analog inputs: thermocouples, temperature transmitter, pressure transmitter, flow transmitter. Variable frequency signals. All inputs other than digital and analog comes under this category. Common examples of variable frequency inputs are encoders, flow meter, strain gauge or load cells, etc. Outputs. The output transmits the signals and displays the status of the connected output points. Outputs are of two types: digital and analog. Examples of digital output: lamp, pilot lights, LED, solenoid valves, contractors or relays, alarms, etc. Examples of analog output: control valve, servo valves, proportional valve, and drives. Wiring of input devices to DI module. Wiring of output devices to DO module. Interface modules. This module is optional and used for rack-to-rack communication in multi-tier configuration. Interface modules can be placed only in slot number 3 in S7-300 PLC. Communication processors. This module is optional and can be used for providing additional communication ports. Function modules. Signals other than digital or analog are connected to function module. Example: high-speed counter module, PID module, weighing module, etc. Yes, I now understand many terms related to PLCs. Not as yet. You need to get familiar with some more, as language of PLCs consists of a unique set of commonly used terms. Let's check these. The PLC is programmed using a specialty program or software on a computer that can load and change the logic inside. Most modern PLCs are programmed using software on a PC or laptop. The function of software is to provide instructions to the CPU and coprocessor modules. Some examples of programming software are RS Logix, Allen Bradley controllers, Simatic Manager, Siemens S7 controllers, PL7, Modicon controllers, Control Builder, ABB controllers, LM90, Fano controllers. RAM. With random access memory, data can be written to and read directly from any address. It is used as a temporary storage area. RAM is volatile memory. Data stored in it is lost when power is removed. A battery backup is often used to prevent data loss during power outages. ROM, read-only memory, can be read from but not written to. ROM is non-volatile memory, so the data is not lost in case of power outage. It is normally used for storing OS of the PLC. EEPROM, electrically erasable programmable read-only memory. EEPROM is used primarily as a non-volatile backup for the normal RAM memory. If the program in RAM is lost or erased, a copy of the program stored on an EEPROM can be downloaded into the RAM. PLC is like a mini computer. Yes, a PLC is much like a personal computer. The difference is that PLC handles multiple configurations and carry out control functions. How does it all work together in an industrial setup where PLC needs to send signals to other devices from remote place? Intelligent input or output modules are used for communicating with other PLCs and computers, which are placed at remote locations. It is important for anyone in automation to have a basic understanding of PLC communications. Let me show you how it works. Let us now learn about communication of PLC. Click Start to begin. PLC needs to communicate with following devices as per field requirement: programming device, HMI, drives, PLC, third-party equipment. Different PLCs use different protocols for communication. Some commonly used communication protocols are multi-point interface, MPI, Profibus, DP, Industrial Ethernet, Control Net. Let us check some of the protocols in detail. Multi-point interface, MPI, is used as a programming device interface. Maximum 32 nodes can be connected to this network. This network can exchange small quantities of data. Default speed or baud rate of MPI communication is 187.5 kilobits per second. Profibus DP. DP stands for Distributed Periphery. Profibus DP is a master-slave protocol with default data transmission rate of 1.5 megabits per second and maximum up to 12 megabits per second. Node addresses are provided in module which holds DP port. Maximum 126 nodes can be connected to this network. Profibus DP connector is 9-pin sub-D type connector. Each node must have unique address. In PLCs, no two nodes in common network can have same node address. Ethernet is a family of frame-based computer networking technologies for local area networks. Siemens introduced Ethernet into industrial automation in 1985. This is suitable for quick transmission of large quantities of data. The number of nodes could be up to 1024. Industrial Ethernet provides fastest speed among all possible mode of communication available, 100 Mbps. Ethernet is the portal to the Internet which allows a PLC to communicate worldwide. Some PLCs have built-in web server capability, allowing access to it from any web browser. PLCs often must interface with other devices. In order to identify each one of them uniquely, address is given in binary or word format. This makes communication with devices easier. Let me tell you more about addressing. The CPU provides unique addresses to all its input and output devices, which are placed in the slots of the racks. This address can be bit level for digital or word level for analog, depending on the type of the module. Byte format is used for addressing in all S7 PLCs. PLC consumes 1 bit of memory for every digital input or output. Each analog I/O consumes 1 word memory. 1 byte equals 8 bit. 1 word equals 16 bit equals 2 bytes. 1 D word equals 32 bit equals 4 bytes. Let us now learn about programming of PLC. Click Start to begin. For programming Siemens S7 PLC, Semantic Manager software is used. Semantic Manager offers 3 types of user-friendly programming languages. These are Ladder Diagram, LAD, Statement List, STL, Function Block Diagram, FBD. These programming languages are convertible to each other with certain restrictions. The number of logics and input-output instructions are limited by memory size of CPU. Programming in STL consumes least memory in CPU. Ladder is the most commonly used programming language. We will see PLC programming using Semantic software. PLC programming starts with creation of new project and hardware configuration. We will be using PLC 300. Double-click on Semantic Manager. Then, after the application opens, click on File, New to open new project. Pop-up window will open. Here, name the project as Training. Then click OK. Once the project is created, first step is to insert the station. Click on Project Name. Insert New Object and select Semantic 300 Station. Once the project is created, double-click on Hardware to start hardware configuration. The term configuring refers to the arranging of racks, modules, distributed input and output racks, and interface submodules in a station window. Rack is the hardware which is configured first. Some rules to follow while configuring rack are: Slot 1, power supply only or empty. Slot 2, CPU only. Slot 3, interface module or empty for S7 300. Slot 4 to slot 11, signal or function modules as placed in the physical system. After hardware configuration, click on Save and Compile icon to save and compile the file. This creates STB file, where hardware configuration is saved. Saved hardware configuration needs to be downloaded. The term downloading refers to sending the program or configuration data to CPU from the programming unit. During this process, CPU goes in stop, and after successful downloading, it will return to normal run mode. Now, OB1, Organization Block, has got created in Semantic Manager screen. Organization Block, OB, is a programming block, which is scanned first by CPU. OB1 is the only cyclic execution programming block, that is, the instructions written in this block will get executed in every scan during CPU run. After opening the OB1, following screen will open where writing logic can be started. So, every program must be OB1? Yes, that's correct. Once OB1 is created, then you can start writing the program. Program structure helps in understanding the block architecture, the call structure, and the dependency of various blocks. It also helps to know FB and DB block connectivity. For S7, we follow structured program. S7 offers following types of blocks to program S7 300 and 400. Programming blocks for S7 PLC. Organization blocks, OB. Functions, FC. Function blocks, FB. Data blocks, DB. System blocks, SFC, SFB, SDB. Let's look at each one of these in detail. Organization block forms the interface between the operating system of the CPU and the user program. OB1, which is responsible for cyclic execution, is automatically called by the system. Other OBs are called at special events or error. Different OBs available with S7 PLCs are cyclic interrupt OBs OB30 to OB38. These are executed when executing a program cyclically or at set interval of time. Error OBs OB80 to OB87, OB121 and OB122. These are executed when errors occur. Hardware interrupt OBs OB40 to OB47. These are executed when there are hardware interruptions. Hardware interrupt OBs have highest priority. Time of day interrupt OBs OB10 to OB17. These are executed at certain times or on certain days. Time delay interrupt OBs OB20 to OB23. These are executed after a specified period of time. Restart OBs. These are executed when CPU is restarted. The three types of startup OBs are OB100, OB101, and OB102. PLC can be restarted on any of the above types as per selection in the CPU properties. Only timers, counters, and memory bytes, TCM, can be made retentive in CPU properties as per grading of the CPU. During warm start, only retentive data remains, rest all data gets initialized. Function. A function is a logic block without a memory. A function is always executed by calling it in another block, like OB1. A function can be used to return a value. A number of functions are CPU specific. A function is written once and used many times. Function blocks. Function blocks are logic blocks which have a memory. The memory is in the form of an instance data block, which is associated with the function. Actual parameters and static data are stored in the function blocks. Like functions, function blocks, once written, can also be used many times. Data blocks. The data blocks are used for storing data and fetching it whenever required and to store resultant data. Data blocks should always be downloaded before downloading the function block. Two types of data blocks are available. 1. Shared data blocks. These are global data blocks, meaning information in this can be accessed and shared by all the logic blocks in the user program. 2. Instance data blocks. These are always assigned to a particular function block. The data in each data block should only be used by the assigned function block. System block. These are pre-configured blocks available in the operating system of the CPU that can be called and used by the user. Different system blocks are system functions, SFCs, which have properties like functions. System function blocks, SFBs, which have properties like function blocks. System data blocks, SDBs, which have properties like data blocks. Hardware configuration of particular PLC is stored in SDB file. Let us now learn about programming instructions of PLC. Click Start to begin. All the instructions available in S7 PLCs are divided into following 6 categories. 1. Bit level instructions. 2. Timer or counter instructions. 3. Comparison instructions. 4. Conversion instructions. 5. Mathematical functions. Integer function, floating point function. 6. Move. Let's look at each one of these in detail. Let us now learn about bit-level instructions of PLC. Click Start to begin. Normally open contact, normally close contact, output coil, invert power flow, midline output, reset coil, set coil, RS flip-flop, SR flip-flop, negative RLO edge detection, positive RLO edge detection, negative edge detection, positive edge detection. Save. Let us now learn about timer or counter instructions of PLC. Click Start to begin. Timers are blocks that count the time as specified by the user and then executes the algorithm based on the time. There are 5 types of timer available in Siemens PLC. On delay timer, off delay timer, pulse timer, extended pulse timer, set storage timer. Parameters in a timer are S. Start input, PI. Remaining time value, TV. Preset time value, R. Reset input, BCD. Remaining time value in BCD format, Q. Status of timer. Take a look at the various timers on screen and click Next to continue. The procedure for programming all 5 types of the timers is same. The maximum time delay provided by S7 timers is 9990 seconds. The basic format for time delay entry to TV starts with S5T hash followed by delay time unit. For example, in S5T-1HR2M3S400MS, 1HR stands for 1 hour, 2M stands for 2 minutes, 3S stands for 3 seconds, and 400 ms stands for 400 milliseconds. BI and BCD usually are left empty. Reset input can be left unused in all timers except set storage timers, and set storage timer is also called set on delay timer, and its output cannot be reset without a trigger at reset input. All 5 types of timers are available in coil form and block form in library. The number of timers available depends upon the CPU. The 3 types of counters available in S7 PLCs are up counter, down counter, and up-down counter. Take a look at the details on screen and click Next to continue. The various parameters in a counter are counter identification number, count up input, count down input, set input for presetting counter, value for presetting counter, reset input, current counter value, hexadecimal number, current counter value, BCD code and status of the counter. Take a look at the corresponding data type for each counter and click Next to continue. Take a look at the various counters on screen and click Next to continue. The procedure for programming all 3 types of the counters is same. The maximum count preset value in S7 counters is 999. The basic format for entry to PV starts with C followed by hash and the relevant number. For example, C#5 stands for a counter of PV 5 counts. CV shows current value counted by the counter, and it can be left empty or given a memory word address. Reset input is used to make the CV 0. Set input is used to change the CV equal to PV input. Output Q becomes high when counter starts counting and having any count. That is, Q is equal to 1 when CV is greater than 0. All 3 types of counters are available in coil form and block form in library and can be used as per requirement. And the number of counters available depends upon the CPU. Counters. A counter is set to some preset value, and when this value of input pulses has been received, it will operate its contacts. Typically, counters can count from 0 to 9999. The maximum count preset value in S7 counters is 999. 3 types of counters available in S7 PLCs are: up counter counts from 0 up to the maximum value. These are called CU. Down counter counts down from the current preset value to 0. These are called CD. Up-down counter counts up and down. These are called CUD. Let us now learn about comparison instructions of PLC. Click Start to begin. There are 6 comparison operators. IN1 and IN2 are compared according to the type of comparison you choose. IN1 is equal to IN2. IN1 is not equal to IN2. IN1 is greater than IN2. IN1 is less than IN2. IN1 is greater than or equal to IN2. IN1 is less than or equal to IN2. Let us now learn about mathematical functions of PLC. Click Start to begin. There are 4 basic mathematical functions. 1. ADD, add, addition. 2. SUB, sub, subtraction. 3. MUL, mul, multiplication. And 4. DIV, div, division. Let us now learn about conversion instructions of PLC. Click Start to begin. 15 types of conversion instructions available in S7 PLC. Let us now learn about move. Click Start to begin. It is activated by the Enable EN input. The value specified at the IN input is copied to the address specified at the OUT output. It can copy byte, word, double word data objects. Move is not a comparison instruction. Let me show you few basic PLC programming examples. It will help you to know how to put all these instructions together. Let us now learn with some practical examples. Reach the programming arena by following the path and open OB1. In OB1, click on Network 1 and start inserting instructions as per the logic. Now, try to make a logic for switching on a lamp when 2 switches are made on together. When you are ready, click Next to compare and check how well you have done. First, reach to the programming arena and open OB1. Click on Network and insert NO contacts and coil. Give address to all instructions. Save and download the program. Click the monitor icon and check the online status of the program. Now try to make a logic for Direct Online DOL Starter. When you are ready, click Next to compare and check how well you have done. Open OB1 and click on Network. Insert NC contacts and coil. Give address to all instructions. Save and download the program. Click the monitor icon and check the online status of the starter program. Now try to make a logic for switching on a lamp after 10 seconds of switch on. When you are ready, click Next to compare and check how well you have done. Open OB1 and click on Network. Insert NO contact. On Delay Timer and Coil, give address to all instructions. Save and download the program. Click the monitor icon and check the online status of the timer BI, and output lamp Q4.1 when switch I1.0 is made on. Now try to make a logic for up or down counting and switch on a lamp. When counting starts, when you are ready, click Next to compare and check how well you have done. Open OB1 and click on Network. Insert NO contact, up-down counter and coil. Give address to all instructions. Save and download the program. Click the monitor icon and check the online status of the lamp Q4.2 and counter value CV by giving repeated switching of input I1.1. Now try to make a logic for star delta starter. When you are ready, click Next to compare and check how well you have done. Open OB1 and click on Network. Insert NO or NC contacts. On delay timers and coils, give address to all instructions. Save and download the program. Click the monitor icon and check the online status of the outputs Q4.1 and Q4.2 when switch I0.0 is made on. To insert symbols with address, right-click on Contact and select Edit Symbol. Wow! SIMATIC looks like a very user-friendly software. Sir, once program is written and downloaded to PLC, then do PLC work on its own as per program? Do we need to periodically check any tasks? Well, several maintenance aspects should be considered once the system is in place and operational. Certain maintenance measures, if performed periodically, will minimize the chance of system malfunction. Also, knowledge of how to troubleshoot issues will help to tackle errors. Let's learn about how to troubleshoot in case of errors. Let us now learn about maintenance and troubleshooting of PLC. Click Start to begin. Programming with foresight, knowledge, and proper handling of diagnostic tools puts you into an advantageous position in error situations. If an error occurs, the CPU writes the cause of error to the diagnostic buffer. When an error or an interrupt event occurs, the CPU switches to stop mode. All the events and faults are registered in the file with timestamp. In case of any abnormality, we can refer to this table for troubleshooting. If the CPU has gone to stop mode, always see diagnostic buffer first before resetting the fault and restarting the PLC. This maintenance tool is very helpful in case of analyzing problems or faults. It enlists all the input and output variables where we can visualize online values and modify all its entries. It also shows the default as well as the forced status of the entities. Various VAT tables can be created and saved having different variables to monitor. Forcing is used to change the value of an address in PLC program. In S7-400 PLC, forcing can be done for all analog input-output and digital input-outputs. Normally, forcing has to be avoided, and if required, then it has to be done after following the procedure and guidelines. To remove all the forcing from PLC, delete forcing option must be used. Reference data is very useful tool for maintenance and troubleshooting. Following options are available in reference data: assignment list, cross-reference, program structure, unused symbols, addresses without symbols. To open reference data, go to Options and select Reference Data, then select Display. If there is any modification after the last reference data viewing, the system will ask to regenerate or update. Assignment list helps the user to find out the available data like inputs, outputs, memory bits, timers and counters to be used. A cross mark in the input-output and bit memory area shows that the bits are already used. Program structure helps in understanding the block architecture, the call structure, and the dependency of various blocks. It also helps to know FB and DB block connectivity. Ramesh, the most important step is being able to take backup of your program and restore it when required. The basic backup and restore task everybody needs to know and should be able to perform. Archiving will create the zip file of the complete project, which can be saved. Following are the steps to archive a project. 1. From top menu, select File and then select Archive. 2. Pop-up window will open. From here, select the project name. 3. Next, select the location on hard drive where backup will be saved. 4. File will be stored on the computer.
Click Next to continue.
To restore the backup or archived file of the program, retrieving is done. Retrieving extracts the content of the zip file of the archived project. Following are the steps to retrieve a project. 1. From top menu, go to File and select Retrieve. 2. Pop-up window will open showing files. Select the archived file with .zip extension. 3. Select location where project will be restored. Retrieving process will start. Once it's over, project can be opened from the location where it was restored.
Thank you, sir, for sharing this valuable information. I'm looking forward to work with PLCs.
Incorrect.